Here we are going to do some of the numerical problems which is happening because of the combinations of a lens and a mirror. It can be any type of the lens and any type of the mirror. The first is like the concept here what we are going to use is that the image formed by the refraction or reflection by the first is acting as an object for the second reflection or the refraction. The first question here on the screen is the convex lens is placed in contact with the plane mirror and at an axial point an object is placed at a distance of 20 centimeter from the combination has an image coinciding with itself. Find the focal length of the lens. This is the question, right? Now for this, what are the things which is taking place? Now if you look at the image, you can see that first the refraction is happening from the lens, then it is reflected back from the mirror, and then again the rays are getting refracted from the lens and final image is being formed. The position of the object and the image are on the same position as you can see, right? The yellow one. Now, this is possible only if the rays fall normally on the plane mirror. Like the object is placed here, you can see on the screen, O is the object, the rays are emerging out, and after the refraction from the lens, you can see that the rays are moving out parallel to the principal axis, right? And this refracted ray, now they will be falling on the plane mirror as we have shown it separately. Now if you can combine these two, you can see that the rays will retrace the path and again fall on the position of the object, right? Now tell me, right from the lower classes you have learned that if a refraction is to be taking place from the lens, when is that the rays go parallel? Yes, you're right. This is when the object is kept at the focus. That means that object distance should be equal to the focal length, right? So here according to the question, it is 20 centimeter. So OC is equal to 20 centimeter, and so the focal length is 20 centimeter, which is the answer. Now the question arises, should you keep the lens and mirror just close to each other? Should they lie in this position? That means when they are attached to each other. Or you can take the mirror further away as I have shown in the diagram below. Like the question is, if the rays fall normally on a plane mirror, they will get reflected back in the same path. Why? Because angle of incidence is equal to 0, and according to the laws of reflection, you know that angle of R is also equal to 0 degrees, right? Now these both are 0 degrees, so the path is retraced. So the final image is also formed at the position of the object, whether the mirror is kept here or it is placed somewhere away, doesn't matter, the image will be formed at the same position, right? Okay, now let us move to the next question. A convex lens and a convex mirror of radius of curvature 20 centimeters are placed with convex mirror at a distance of 30 centimeters from the lens. For a point object at a distance of 5 centimeter from the lens, the final image due to the combination coincides with object itself. What is the focal length of the convex lens? This is the question. Now look at the diagram. Yes, there is a lens, biconvex lens, and after the rays from the object get refracted from the lens, they fall on the mirror, which is a convex mirror, and they are retracing the path. That means after reflection, they are following the same path. The rays are not able to come inside, but they are retracing their path as shown, right? Now, when is this possible? This is possible if from the reflection of the convex mirror, the rays are retracing the path. As per the question, in the case of the convex mirror or any of the spherical mirror, the object and the position of the image will coincide only if the object is kept at the center of curvature. That means if this mirror was not there, these rays would come straight and meet at this position C, which is the center of curvature of this mirror. Only then this is possible, right? Now we can consider the same case as if this mirror was not there and the rays are finally converging at the position C, right? So we can say that the distance OC1, this is OC1, and this distance as it is shown here, we can write it here itself, and this distance is equal to 25 centimeter. And for the image distance, you have to add up C1P plus PC, that means it should be equal to 30 centimeters plus 20 centimeter, which is equal to 50 centimeter. So that is equal to V. Now you can see that according to the coordinate systems, so this becomes negative, U is negative, which is equal to 25 centimeters, and V, because it is measured from this optical center of the lens to the position where the image is formed, and it is along the same direction as that of the incident rays, so it has to be taken as positive. So you have got the value of U and also the value of V. Put it in the lens formula and finally get the answer. What is the lens formula? You all know that the lens formula is 1 upon F is equal to 1 upon V minus 1 upon U, and substitute the value. 1 upon F is equal to V, I know it is equal to 50, and U I know that is equal to minus of 25 centimeter. So I have got, after calculation, the focal length of the lens is equal to 50 by 3. So I should write F is equal to 50 divided by 3, that much of centimeter. Got it? Third question, a convex lens of focal length 20 centimeter is placed coaxially with a convex mirror, radius of curvature 20 centimeter. The two are kept 15 centimeters apart from each other. A point object is placed 60 centimeters from the convex lens. Find the position of the image which is formed by the combination. First, the solution, we need to consider both the mirror and the lens together. As per the question, you are given that there is a combination of a lens and a mirror. The object is placed 60 centimeters from the lens, and there is a mirror which is placed at a distance of 15 centimeters from the mirror, right? Now, we have to consider the refraction from the lens and the reflection from the mirror. So, for that, first we will consider the reflection which is from the lens, and for that we need to consider the diagram of only and only the lens and discarding the mirror. Now, you can see that this is a lens and the object is placed at a distance of 60 centimeters as given in the diagram, right? You are given that the focal length of the lens is equal to 20 centimeters. So, simply you can apply the lens formula. 1 upon F1 is equal to 1 upon V1 minus 1 upon U1, and put the values here. We know that F is equal to plus 20 centimeters, U, that is the object distance, is equal to 60 centimeters. So, substituting the values, we have calculated the image distance V1 as 30 centimeter from the optical center of the lens, and this is equal to 30 centimeter. Right. Now, once you have got this, now look at the diagrams, both of them together. Now, what do you see? This is the actual question and this is the part of the question which we solved, right? Okay, the mirror is now placed at a point P here. This is the spot, okay, and the image is formed at I1. You can see exactly the I1, right? Now, for this, now the calculation of the actual image distance, this is the image, and the image distance is to be calculated from P to I. So, for that, you need to apply the mirror formula, right? So, for the mirror, I need some data. What are the data which is given to you according to the question? It is given that the radius of the curvature of the mirror is equal to 20 centimeter. So, the focal length of the mirror will be equal to how much? 10 centimeters. You need to apply this all in the mirror formula, and in the mirror formula, when you substitute, you have got the value of u2 is to be calculated. Now you have calculated this distance v1, and v1 you got it as what? That is equal to, you got it as what? 30 centimeter. So what will be the value of this u2? You know, the whole thing is 30, this distance is equal to 15. So naturally u2 will be equal to 15 centimeter. That means the image distance for the object, that is equal to 15. Now plus 15 or minus 15? It has to be plus 15. Why plus 15? This is because pi, it is measured in the same direction as that of the incident ray. As per the sign convention, the object distance for the mirror has to be positive. So I should take this as plus 15 centimeter. We know the focal length of the mirror, we calculated it as 10 centimeter. Now applying this in the mirror formula, we get the image distance again to be plus 30 centimeter. That means where is the image formed? The image is formed 30 centimeter from the pole of the mirror, and the image formed is virtual. Why virtual? Because the object is here and the image is formed behind the mirror, as you can see here, so it is virtual, right? Okay, let us move on to the next question. Let's move on to the fourth question. A convex lens of focal length 20 cm and a concave mirror of focal length 10 cm are placed coaxially 50 cm apart from each other. An incident beam of light parallel to principal axis is incident on the convex lens. Locate the position of the final image which is formed by the combination. As you can see in the figure, there is a lens and a mirror. Parallel beam of light is coming and striking the lens. As you know, if a parallel beam of light strikes the lens, it has to converge at the focus. So the focal length of the lens is 20 centimeter. So the distance OI1 is also equal to 20 centimeters after the refraction from the lens. Now we know that now the reflection has to take place from the mirror, right? Now for the mirror, the reflection, the object distance for the mirror, that is the distance between the lens and the mirror, it is given as 50 centimeter. So U for the mirror is 50 minus 20, which is equal to minus 30 centimeter, right? Okay, now we already given that the focal length of the mirror is 10 centimeters. Substituting the values in the mirror formula, 1 upon F1 is equal to 1 upon U1 plus 1 upon Vm. We calculated the value of Vm, that is equal to minus 7.5 centimeter, right? Okay. Let us move on now to the fifth question. The radius of curvature of the convex face of the plano-convex lens is 12 centimeter and the refractive index is 1.5. The first part of the question says that find the focal length of the lens, right? Now you are given a plano-convex lens. Now this appears like this. One side it is plane and other side it is a convex part. So here we have to simply apply the lens maker's formula. 1 by f is equal to mu2 minus mu1 divided by mu1, and that is multiplied by 1 upon r1 minus 1 upon r2, right? Okay, the value of mu2, which is glass, which is 1.5, mu1, if nothing is given, it has to be taken as 1, and r1, if I consider the convex surface to be the first surface, that means the r1 will be having a value of 12 centimeters, R2 is plane, so it has to be taken as infinity, right? Now when I apply this to the lens formula, I get the focal length as 24 centimeter, right? Now if I happen to send the rays by the convex side, I know that it will be acting as a converging lens, and if the rays are sent from the opposite side, that means if I happen to send the rays initially from the plane side, then applying the same formula, I'll get the focal length of the lens will be, that is minus 24. That means it becomes a diverging lens, right? Now it all depends, the focal length of this lens will depend entirely upon from the direction in which the rays of the light are sent, right? Okay, now let us move on to the second part of the question. In the second part of the question, you are asked that if a beam of ray which is parallel to the lens is incident on the convex region. Naturally, it cannot be incident from the mirror side, so it is going to be incident from the lens side. So, where will the rays finally converge? That means indirectly they are asking you to find out the focal length of this combination. Now, here three things happen. First, the rays gets refracted from the lens, then it gets reflected from the mirror, and the third again it gets refracted from a plano-convex lens, right. So, if the rays which are parallel to the principal axis get refracted by the convexo-plane lens, right. So, the focal length of the lens we already have calculated, it is equal to plus 24 centimeters. The rays will be now converging at plus 24 centimeters, right. Then second part, it is then reflected by the plane mirror, right. So, the plane mirror, the image distance is equal to the object distance. If the object is at plus 24 centimeter, the image has to be at minus 24 centimeters. Why? Because the object is virtual, the image has to be real. Now, the third part, again the rays are getting refracted from a plano-convex lens, right. The third part, you can see that the first is a convexo-plane and the second is a mirror, third is a plano-convex, right. So, in that case we know that the focal length of the plano-convex is minus 24. In the case of the convexo plane, it was plus 24 and in this case it is minus 24. You know that it is equal to minus 24. So, if you put it in the lens formula, 1 upon f is equal to 1 upon v minus 1 upon u. So, on calculations we get v is equal to minus 24. That means the final image is formed at minus 12 centimeter from the lens. So, you have to consider that the combination has got a focal length of minus 24 centimeter. Now, let us go to the third part of the question. Now, according to the third part of the question, he is asking you to actually calculate the image distance when a point object is placed on the principal axis 20 centimeters from the lens. Now, we have already calculated the focal length of the combinations. We are also given the object distance. All that you have to do is find out the image distance using the mirror formula. Why? Because this combination acts as a mirror, not as a lens, but it will act as a mirror. So, in that case, you have to substitute a mirror formula, not the lens formula. So, we know the lens formula is equal to 1 upon f is equal to 1 upon v plus 1 upon u. We know that 1 upon v is equal to 1 upon f minus 1 upon u. Substitute the values and you know that v is equal to minus 30 centimeter. That simply tells you that the final image is formed at minus 30 centimeter, that is in front of the combination, right? Okay, hope you understood it.